Today, we're diving into a story about a gorgeous star cluster. But, this isn't just any cluster. This is Messier 7, an object that was first written down almost 2,000 years ago, and then became a critical guidepost for one of our most ambitious journeys into space. It's an incredible story that connects ancient astronomers with a modern robot hurtling towards Pluto. Okay, picture this. It is January 2006. The New Horizons spacecraft blasts off, kicking off this incredible, nearly decade-long voyage across 3 billion miles of space. Its destination? The far-flung, mysterious world of Pluto. I mean, this was the longest and farthest any probe had ever traveled to reach its main target. But right after launch comes that first moment of truth. See, you can test everything you want in a clean lab, but then you have to strap your delicate instrument to a giant rocket, which is really just a very, very controlled explosion. The shaking is just intense. So after surviving all that, the mission team had one single, terrifying question on their minds. Did the main camera, a super sensitive instrument called LORRI, even survive the ride? So they pointed the camera out into the black. They opened its protective door, and they waited. About 5 minutes later, the first image came back, and the lead engineer, Steve Connard, shouted the 3 words that everybody in that room was desperately hoping to hear. "I see stars." The camera worked. The mission to Pluto was really on. So what exactly were those stars? Well, they weren't just some random patch of the sky. The team had deliberately pointed their brand new cutting-edge camera at a very specific and very, very ancient landmark. And this is where our story takes a huge leap back in time. We're talking almost 2 millennia. Just look at this timeline. It's amazing. Way back in 13 AD, the astronomer Ptolemy jots down a note about a nebulous cluster, a little fuzzy patch of light. Fast forward over 1,600 years, and Charles Messier adds it to his famous catalog as Messier 7. And then, nearly 250 years after that, it becomes the very first thing seen by a spacecraft on its way to the edge of our solar system. That's a legacy that spans almost 2,000 years. So what exactly is Messier 7? Well, it's what astronomers call an open cluster. The easiest way to think about it is like a stellar nursery. It's a big group of stars that were all born around the same time from the same giant cloud of gas and dust. They're basically stellar siblings, all still hanging out together before they eventually drift apart over millions of years. So let's run through the quick stats. Its scientific name is NGC 6475, but most people call it Ptolemy's cluster, which is a great nod to the guy who first wrote about it. You can find it in the sky down at the tail of the constellation Scorpius, and it's about 980 light-years away from us. It's a pretty cozy family with about 80 stars in total. All right, so this cluster is way more than just a historical landmark. Now that we know what it is and where to find it, let's dig into what modern science has actually figured out about this thing. First up is its age. The stars in Ptolemy's cluster are about 220 million years old. Now, to you and me, that sounds incredibly ancient, right? Dinosaurs were still roaming the Earth when the light from these stars first started its long journey to us. But in cosmic terms, these are basically teenagers. Our own sun, for comparison, is over 4.5 billion years old. And it gets even more interesting. The whole cluster weighs about 700 to 800 times as much as our sun, and it stretches a whopping 25 light-years from one end to the other. What really makes it a goldmine for astronomers, though, is its diverse mix of stars. It even has some really interesting chemically peculiar stars, which have unusual elements in their atmospheres. This makes the whole cluster a perfect natural laboratory for studying how stars work. And this quote from a research paper really gets to the heart of why clusters like this are so valuable. Co-eval and co-environmental. It's a bit of a mouthful, but it's just a fancy way of saying all the stars have the same age and they're made from the same initial stuff. This is huge for scientists because it lets them isolate other things, like a star's mass or how fast it spins, to see how those factors affect how a star revolves. Okay, so we know it's ancient and we know it's scientifically fascinating, but that still doesn't quite explain why the New Horizons team chose this specific cluster for that all-important make-or-break first picture. I mean, out of the entire sky, why this one? Well, it really boiled down to 3 very practical reasons. First, its stars are nice and bright, so they're easy for a camera to spot. Second, they're spread out really well across the camera's field of view. This meant the team could check that the entire detector was working, not just one little spot in the middle. And third, and this one was absolutely critical, it was in a safe direction to look. Now, to understand that safe direction part, we just need a quick definition for this term, solar elongation angle. Don't worry, it sounds technical, but it's really simple. It's just the angle between the sun and whatever you're looking at from your point of view on the spacecraft. So why is that angle so important? Well, because the absolute last thing you ever want to do is accidentally point your super sensitive billion-dollar space camera anywhere near the sun. It would completely fry the detector, instantly. So to be safe, they needed a target that was more than 90 degrees away from the sun. Or to put it really simply, they had to keep the sun behind them. And Messier 7 was in the perfect spot to do just that.
And, this role as a celestial benchmark wasn't just a one-time thing. Messier 7 is actually part of a grand tradition in space exploration, where these ancient star clusters are used over and over again as these crucial calibration targets for our most advanced instruments.
In fact, as New Horizons kept flying deeper into space, its position relative to the sun and the stars was always changing. By 2013, Messier 7 wasn't in a safe viewing spot anymore. So what did the team do? They just switched their calibration target to another famous open cluster, this one known as the Wishing Well.
And here's the best part. That other cluster, the Wishing Well, has its own incredible claim to fame. It was the first light target for the Hubble Space Telescope. How cool is that? You've got two of the most important space missions in modern history, Hubble and New Horizons, and both of them relied on these beautiful, ancient open clusters to make sure their eyes were open and ready to explore. It really makes you think, doesn't it? Something that started as just a fuzzy patch of light, noted down by Ptolemy almost 2,000 years ago, becomes a vital systems check for a probe pushing the very boundaries of human exploration. It just leaves you with this fascinating question. What other ancient guideposts, recorded by our ancestors and hiding in plain sight, are just waiting out there to help us take our next great leap into the cosmos?